Okay, this is a re-recording of the October 2nd lecture um, to include video as well as the audio, and also at the same time to add a little more content and actually to make the entire recording so much shorter. Alrighty, so let's get started. First, the quiz 2 is postponed until October 9th, next week. The main reason is that I wanted to see everybody in the class work on some math projects to get some practice with Python math stuff. From the submissions, it was pretty clear that people really hadn't done a whole lot of coding and practice with math stuff. So the quiz is next week. All right, the one-on-one meetings. They're required weekly, ideally in class. I want to know, where each of you are with your project work. If we don't have a weekly meeting, things kind of begin to drift away. You end up possibly wasting a lot of time being stuck on something, not sure what you should be doing. So it's important that we meet every week. Not meeting first impedes your progress with projects, but it also will affect your grade. I keep track of if we meet or not. And if there are a lot of weeks where we didn't talk, that will be taken into consideration when your grade is calculated. The meeting should be no more than 5 minutes. So either during class or if somehow it doesn't happen during class, then during the week between classes. A 5-minute meeting, that's kind of hard to say you didn't have time for a 5-minute meeting. So, okay, so everyone, we should talk every week. And we're going to revise sort of the meeting scheme a little bit. That hopefully it'll be possible to meet with everyone. It's about 30 people in the class, but still, I think it might be possible to meet with everyone in the class during class time, so there won't be anyone who needs to meet outside of class. The purpose of the meetings will be specifically to discuss sort of where you are with your project goals and to set new goals once you complete the ones you're working on. That discussion, I'm looking much more for your thinking than your code. I don't really want to, I will look at code, you're right, but what I'm looking for in that meeting is your understanding of the thing you're currently working on. And I'm going to demo fairly extensively in a few minutes, kind of what I mean, quote unquote, working on. The meetings, these short meetings, are not tutoring meetings. They're not, I can't figure this out. Can we have a long conversation about, can you walk me through this? If you do want to discuss course material or maybe even project algorithms or something like that in more depth, we can have another meeting, but it can't be one of the in-class meetings because I want to make sure that there's time to meet with everybody. It's not fair to other people if a very significant part of class is taken up by one person in particular for detailed help with either class material or their project. I may ask a student who's completed the material they're working on to briefly assist you. One of the reasons for that is it's beneficial to the student who's helping you. I find that teaching continually reinforces my understanding of programming. So it'll be beneficial to both the student who's being helped and the student who's helping. In the case that you sort of feel like you need hours of tutoring, the department and I can refer you to a tutoring service. There are quite a few companies and individuals that are quite good at tutoring Python. So just let me know if you're interested. Okay, so the meeting procedure is going to change. It's going to be strictly very, very short, ideally in class, at least once per class period, possibly more. This past class had some meetings that were very, very short. I think I talked to the majority of the people in the class, even though we didn't do it for the entire class period. So I'm pretty sure for the entire 2 3/4 hours, we can have a meeting or possibly more than one. Rather than call you up sort of in alphabetical order as I've been doing, sort of have new sort of rules for when to have a meeting. The first situation when you should request a meeting is when you're done with all the goals and tasks we agreed on in our last meeting, so that I can review what you did and kind of give you the go-ahead to go to a new set of goals and tasks. Another reason to request a meeting is if you get stuck on completing a task. I don't want you kind of spinning your wheels, spending a lot of time on a task. So the point of that meeting would be to let me know that you're stuck on a task, and we'll try to work something out. And it's possible I might be able to help you with a little bit of quick guidance, or to direct you to somebody in the class who can help you, or possibly to break down that task into smaller tasks that then will allow you to keep making progress. The third reason to request a meeting is if we've not met by 8 p.m. during a given class, put your name on the list. That way, in that remaining 45 minutes, I'm going to try to meet with the people who I haven't yet met with to make sure that we have at least one meeting. You request a meeting by just writing your name on a list on the board, on the blackboard in the classroom, and just kind of go through in the order in which people put up their names. At each meeting, take some notes to kind of write down, what the agreed upon goals are, and bring those notes to the next meeting, so that we kind of know what we agreed on, and can kind of review your progress in that regard. All right, in terms of project work, no matter what you've been working on, or how far along you are in that project, put it aside for now. If you're working on poker, or you're working on dot matrix, I'd like everybody to get some practice with the math projects, and we'll probably work on math projects for the next 2 classes. So put those projects aside. They're not going to be the topic. We're not going to be discussing them in the meetings. We're going to be talking only about the math projects in the meetings. There are 4 projects, project write-ups in the math area on Blackboard. And this video is going to demo how to work through these projects. One of the things that I've noticed is that people are working a lot harder than they really need to. I want to sort of demonstrate how to use that list of unknowns to make your projects a lot easier. So the net result of this is you should feel like you're, once you start using this technique that I'm going to demo here, you should feel that you're kind of making steady forward progress. You're able to complete programs. I know that some people have kind of gotten stuck on things, and they've spent like a class or 2 on, just trying to get, one project to work. The easy projects are really kind of designed that, even the intermediate ones, that, you probably should be able to complete an intermediate one in 1 class period. And I think part of the issue with not being able to complete it in 1 class period is sort of taking the approach of sort of, well, I know what the program is supposed to do. I'm just going to try to write the code for it. That's a really hard way to go about doing the project. The list of unknowns is, and working through the unknowns is a technique. It's not necessarily a particularly obvious technique, but it's a way that's going to make you work through projects much more quickly. And once again, I'm going to demo this in a few minutes. And most of you have already seen this. But the important thing when you're watching this is don't think of this as I'm providing recipes for doing these projects, but rather kind of note like what what the process of using the unknowns is. It's supposed to help you think through the project, and I'm much more interested in your thinking than your code. Submitting, working code is fine, and well and fine, but what you should also submit is the how you work through your unknowns, and the reason for kind of the thinking part of the project is that once you sort of think through the different little pieces, actually writing the code becomes fairly straightforward, and we'll see that in a few minutes. All right. Each of the projects has a list of unknowns, and I talked a bit about what an unknown was really in the term, but I'm going to kind of review what unknowns are and maybe add a little bit to what I didn't really go into as much depth as I'm going to now in the class. So this is, if you were in class, you might want to kind of carefully follow what I'm presenting in this part of the video here. Okay, an unknown is a statement that begins with I don't know what I don't know is. Okay, so examples are, I don't know what data, what I don't know is what data is involved in my project. Or what I don't know is how to compute, for example, the monthly payment for a loan. And so neither one of these things involves writing code. One involves sort of thinking through and saying, okay, I've been given a project statement. I need to calculate something or, generate something to display. But underlying it all is some sort of data. And you have to kind of think about what data is involved. Once again, you don't need to, write any code for this. To answer that question, just write a little bit of text. Likewise, for how to compute a monthly payment for a loan, that's not a programming question, but it's the formula. What's the formula for computing a monthly payment? So, so a lot of unknowns are resolved by just thinking about things, writing things down, like in the case of the data, or looking up, a formula. Usually the projects will provide the formulas you need, so you won't have to go really digging too far for the formulas. Okay. One of the sort of barriers to a lot of programmers using this unknowns technique is they're concerned that by saying they don't know things, that people will think, oh, you're obviously not a good programmer because you don't know things. And the truth is, all the projects I've ever worked on, the programmers involved initially don't know most of what they need to know to write the code for a project. A lot of the projects actually, there's no guarantee that you're going to be able to figure out what you need to know to write the code. None of the projects in this course are like that. I've had a whole bunch of projects where I didn't know, where to look for the knowledge for, for the project. In some cases I got lucky. In some cases I never figured out what I needed to know, and so then the project, did not succeed. And sometimes I kind of got lucky and figured things out, and it was pretty cool to come up with something new. All right, good programmers are continually identifying what they don't know. Bad programmers are the ones who think they know it all. And they dive into writing code, and before you know it, they get stuck and time begins to fly by and their projects are very late. So by saying, oh, this is what I don't know is the best way to kind of stay on schedule, because then that sort of focuses you on figuring out what you don't know, telling other people what you don't know, because there might be people who can help you and tell you what you need to know. So, all right, so the point of unknowns is to identify what you need to figure out before writing the final program. So it's not about writing code. It's some of it's writing code. Like, for example, what code do you write to, save some data to a file? Well, you eventually have to write some code for that. You can't just say, so write some text and say, oh, I know how to do that. In that case, you do need to write some code to prove out that you, in fact, can write some data to a file. But that's we'll kind of get there. In fact, in the demonstration I do, there'll be a mix of just writing some answers with a few words, and in some cases answering an unknown or resolving an unknown by writing some code. And once you get your knowledge, like for example, figure out how to compute the monthly payment for a loan, then it's pretty easy to write the code to do the computation. You should not be stuck there. I mean, you know how to do, you know what the formula is. Now all I have to do is write the Python code to, for that formula to do that calculation for you. All right, this is some stuff I didn't cover in class, but I think it's kind of good to know, even though I won't expect you to come up with lists of unknowns, but I kind of want to give you a sense of where the unknown questions or unknowns come from. Each project usually has one overarching unknown, which is, and then there's 3 categories of unknowns that kind of flow from that overarching unknown. And that overarching unknown is just, what is the specific purpose of the program or project? The way you state it is, what I don't know is what the program is supposed to do. And the project statement usually provides, in fact, not usually, provides that information. It's usually at the beginning. And it's, project statement is something like, for this project, write a program that computes the monthly payment for a loan. So, for example, we do have a project here, and it's like these 2 sentences or 2 paragraphs effectively resolve that overarching unknown. You're going to write 2 programs, one to compute the monthly payment for a loan, and another one to figure out the interest rate that's going to allow you, basically to allow your loan payment to fit your budget. And we'll get to that a little bit later. So the overarching thing is just the purpose of the project and the program you're going to write. And oftentimes, we don't even realize that, when we know we're going to do a project, but we haven't read the opening stuff, we have an unknown there, and reading those first few lines resolves it without you almost not even realizing it. However, okay, there are 3 categories of unknowns that the project write-up may or may not resolve. In some cases, the write-up will provide the answer. You'll just have to go read the write-up carefully. For example, a good example is the form. Typically formulas will be provided, but some of the stuff, it'll be stuff you have to think through. And the 3 categories are what data is involved, what's an appropriate program structure, and what algorithms or formulas are involved. I talked a little bit about data earlier, so and I'll go into detail about these 3 in a moment. And I haven't actually been saying, okay, these unknowns are the data ones, these are the program structure ones, and these are the algorithm ones. But if you went through any of the projects, you'd probably be able to figure out which category each of the unknowns is from or falls into. All right, so what data is involved? Okay, you think about 2 things for these types of unknowns. What data is involved? So this actually has nothing to do with programming. It's, for example, for the loan payment thing, you need to know the amount you're borrowing and the interest rate, and how long is the loan for. Some numbers you'd need to have if you're even doing this on paper. the second part of the data unknowns is how will this data be held? And that's a program specific thing because you're using some sort of um, uh, programming structure, like in Python, you might be using a variable, floating point variable, or an integer variable, or a list, or a dictionary, or something like that. And once you identify what data is involved, oftentimes it's pretty obvious how the data should be held. There are, in some of the more complicated projects, the data is going to be held kind of rather cleverly. Python kind of opens the door to doing some rather clever things. If you've worked through the dictionary chapter in the reading, you've probably seen some of the clever things that you can do with dictionaries by putting data into them in a particular way. Typically, for the more clever approaches, the project write-up will tell you to use that approach. And you've already probably encountered kind of one way, one sort of recommendation is that the dot matrix project, had you holding the dot matrix letter data. Each letter is a list that contains 5 strings. So and it's probably not something you would have decided on your own. In order to kind of give you guidance, the project write-ups will typically be very specific about the things where you should just kind of follow a particular approach. Okay, all right. So unknown category 2. This is something, or B, which is, we didn't really talk about this in class much, but I think it's it'll help you answer. Typically, there'll be a question about the program structure. It's in the form of sort of like write a bunch of comments to kind of outline your program. Okay, and you've encountered a bunch of programs as you've been doing your exercises, and there's actually not too many different types. So the important thing is to remember that that there are types, and there's not too many types that we'll be using. And the first type is called a linear type. And on chapter 5, page 3 has an example of a linear type, which is okay. So this program here, a linear program typically does something, some initialization, and does some things. So initializes some variables, and then does some things with the variables, and then just ends. So it just kind of like runs from start to finish, line by line by line. It's called a linear program. And then there's a second kind of program. It's called a looping program. And there's a couple of different types of looping programs. One of the looping programs is this one here. This is, there's basically 2 types of looping programs. A looping program that does a certain specific number of loops, like this one here. It does this. Actually, it goes through this loop 5 times. Or another type of looping program loops until some condition is met. That's instead of a for loop, you typically use a while loop for that. And so that is an example in this chapter also on page 38. Okay, so this program, once again, it's all the programs typically initialize something at the beginning, and then and in the case of looping programs, then they loop. And this one loops until, as long as x is less than y, it keeps looping. So when that condition is met, as long as this condition is met, as long as this condition is met, it keeps looping. But then when x equals y, here in the output here, it doesn't always say x is less than y in each of the outputs. The loop ends. So this structure here is it's a looping program that continues until, well, it continues until a condition is met. That's typically the way that's stated. And when you are asked what kind of, what's an appropriate program structure to outline your program, you decide which one of these guys, which of these types you want to use, but then you have to kind of put some meat on the bones and sort of add some comments that are specific to your application. So that's going to sort of identify in more detail what's going to go on in your program. And I'll demo that as well. So if you encounter this, question about program structure and the unknowns, this is a good place to go back to. Is it a linear program, or does a situation call for a linear program? Does it call for a looping program? If it calls for a looping program, should it be something that goes? Is it going through a fixed number of things, or is it going to loop until some condition is met? So, and then you go from there. All right, so the third category, what algorithms or formulas are involved? This is typically the hard part of projects. More often than not, the algorithm or formula will be provided to you. Sometimes it's really difficult to actually kind of put an algorithm in writing. So you'll have to kind of think through, but hopefully there'll be a lot of suggestions, a lot of guidance. And even with very explicit explanations, you kind of have to kind of, as the expression is, get your head around the logic of what the algorithm is asking you, or what the formula is asking you to do, or asking your program to do. So this is kind of where things usually kind of get difficult. But the write-ups will try to make it as easy as possible, because I don't want people to get stuck. I don't expect you to invent algorithms, unless you want to. So for example, the project write-up for the loan project will provide you with the formula for computing the monthly payment. The people who have done this project already have seen that formula. By the way, this type of unknown, more than any of the other ones, reveals other unknowns, and the demo is going to show you that. So you might have something, you might write an answer to an initial unknown, and then say, but how do I do this part of my answer? So we'll see. You'll see what I mean by that. But all right. So here's kind of a crazy. You got actually most of the class already knows how this will go. But imagine you're asked to write a program that computes the value of pi, 3.14159263, I think is whatever, by throwing darts. Okay, so would you even know where to begin to write such a program? And I wouldn't expect, well, in fact, a lot of programmers, even some fairly experienced programmers, would probably kind of be left initially a little speechless if asked to do this. But the demo, I'm going to actually do that demo right now to show you how to produce that program. We'll actually have a program that calculates pi. All right, so that project is this one here. And the very first thing to do when you get a project is you should start with an empty file and go down to your unknowns and then paste them into your Python file. And the rest of the demo will in fact continue in this Python file. All right, so we'll park this guy here and we'll go down to the unknowns. You might want to read through this, but I'll select everything here. It lets me select it. All right. So copy and paste it in there. Make it a little bit wider. Okay, so what we're going to do with this is turn it all into a comment. Three little quotes. And then I'm going to add a bunch of white space to make this more readable. Okay, so we technically have a Python program here. Just one big comment. All right, this, by the way, is how you should approach your any project that you start. The very first thing you should do. Don't start writing code. Just go to the write-up, copy and paste it in. Do what you just saw me do. Okay, so now we're going to start working on these unknowns one at a time and start at the beginning here. In fact, we're going to isolate our very first unknown in a separate comment. And the rest of these guys are still in their one big comment. And so the question is like how to represent the dimensions of the board in the circle. Oh, well, let me actually talk about what the issue is here. So you're going to write a program to calculate pi by throwing darts. And this is the dartboard. It's a square within an inscribed circle. And the general idea is if you throw enough darts, there'll be relatively uniform coverage over the entire square. Some of the darts will land inside the circle, some will land in these little portions outside the circle, you'll have pretty uniform coverage over the whole square, both inside and outside the circle. And if you throw enough darts, it turns out that the fraction of the darts that land inside the circle will be proportional to the area of the board occupied by the circle. Okay, so you don't really have to. So the point is that, let's see if I can see this a little more clearly, that the ratio, like say if you throw 1,000 darts and 700 land inside the circle, so the ratio of 700 to 1,000 is going to be the same as the area of the circle to the area of the square. And this leads to some formulas here that these two formulas, you calculate pi using this formula with this number alpha. And alpha is the number of hits that fall inside the circle divided by the total number of hits. So like if the number of hits inside the circle, let's say if the total number of hits is 700, so the entire dartboard was hit by 1,000 hits, and 700 were inside the circle, then alpha is 0.7, or let's say 800, so 0.8. And so then you use this formula to calculate pi. So you're 0.7 or 0.8 times 4, hopefully around 3.14. Right. So each dart toss is going to be simulated using a function from the random package. And we're just going to have a lot of random tosses and hopefully cover the board pretty thoroughly and uniformly, and then use those results to calculate pi. Right? So, and as we work through this, we might come back to this write-up just to review that. All right, so let's go back to our program here. Okay, so how do you represent the dimensions of the board and the circle? And the suggestion is to use one variable. Okay, so if we go back to our diagram here, imagine, you just have to, you're asked, what one, there's a bunch of numbers here. For example, this is the width of the square, the height of the square, the diameter of the circle, the radius of the circle. What would be a good, what could just one of those numbers tell us? Like, for example, if I know the width of the square, do I know the diameter of the circle? In fact, it turns out you do. It's exactly the same. Same with the height. The width and the height, because this is a square, are the same. And they're all the same as the diameter. So what we're going to do is we're going to answer this question here for our first unknown. We're just going to say the dimension, let's say, right, proper English, the dimensions, represent the diameter of the circle. So that, if you want to write a little bit of code, you can do that. I'm going to comment out the code just so that if we do have some code we want to run, this code doesn't end up messing things up in some way. So you could say diameter equals some number. We don't actually the project specification didn't indicate how big the square is, so you can just pick some number. Then that's another reason to comment this out. And so you're done with the first unknown. So we're going to use the diameter, and that using whatever we need to calculate for the square or the circle, we're going to go back and rely on this diameter variable. Okay, so we need some more variables. By the way, notice that these are the data ones. Okay, so so how are we going to keep track of the total number of hits? I'm going to sort of follow fairly closely to what we did in class. And someone suggested that we have a counter variable. Each time we throw a dart, we'll increment this guy. So I'm going to write a little bit of code. Let's go along with that. And initially it's going to be 0, and then we're going to increment it each time we throw a dart. So that's the code for it. So in a matter of like just a couple of minutes, we've knocked off 2 unknowns. So, you might sort of feel like, well, I need to write the whole program. No, you don't. You should focus just on the question, how to represent the dimensions of the circular board. We're going to represent it, with this diameter variable. So if we need the height or the width of the square, we can just, we can create a new variable, say height or width, and say it's equal to diameter. So everything feeds from diameter. Or how to keep track of the number of hits. This is the variable we're going to be using. Okay, so that's all you need to write. You don't need to write, you only need to write one line of code. We're not looking to write the whole program yet. We'll write the whole program at the end after we've worked through all these unknowns. Okay, so now we're going to work on a third unknown. In a matter of 5 minutes, we're already working on a third unknown here. So how to keep track of the number of hits inside the circle, okay? We don't know how to calculate that, but we want to keep track of them. So even if we don't yet know how we're going to do that, okay? So we're going to have another counter variable inside the circle counter. Okay. And I'm going to add a little code here. And we're in fact going to call it inside the circle. That's also going to start at 0, and it's going to increment each time we get a hit that's inside the circle. Okay, and once again, it's commented out just so if we have some code down here. In fact, we will have some code that we'll run, and I don't want this code to run and possibly mess things up. Okay, so so now we could have asked what data is involved, dimensions of the board, um, total number of hits, or total number of throws, total number of hits inside the circle. It's kind of implicit. We went straight to sort of identifying how we're going to hold that data. So it probably would have been fair to first ask what data is involved. Okay, now we're on to program structure. So what's the best program structure? So is it linear? Are we just like initializing some variables, using them, and that's it? Or are we initializing some variables and then running a loop doing a fixed number of things? Or are we initializing some variables and running a loop until some condition is met? Since we're going to throw a certain number of darts, we're going to have a looping program, with fixed number of loop, whatever, fixed number of whatever loops. So that's that means we're going to use a for loop. But when we meet in our meetings, this is what I'm looking for. That you've thought this through, so you can tell me this, okay? And what I'll kind of expect for the structural stuff too is that you write a little comment-based outline. So all the programs always initialize some variables, and then you write something like for each throw, each dart throw. Even like tab in, simulate a hit. Find out if it hit inside or not. And you want to maybe increment and hit inside the circle. Hit on the right. If hit is inside circle, increment. Okay, so then now we're going to calculate pi with this. And before we can do that, we need to calculate alpha. And or we're just going to say calculate pi. We don't. We're just asking about structure, not the formulas here. So calculate pi. Results. Throws. We know we have got a formula, but this is just a program structure. And maybe even print out pi. Okay, so that's comments that outline our program structure. We're not going to get into the details of how we're calculating pi with the results. We're not getting into details here now how we simulate a hit. We're not getting into details about finding out if it hit inside the circle or not. But this is an example where something you write now raises questions like, how do you simulate a hit? Okay, how do you find out if a hit is inside the circle or not? I've anticipated those things, so I've written some unknowns for it. But if you were working, on your own with nobody to write the unknowns for you, this is how you generate some of your next unknowns, or some unknowns you'll need to resolve. So and once again, you could walk through this on paper. This has nothing to do with programming per se. This is just kind of a recipe for how you would use this process to calculate pi. You could actually have a physical dartboard with a bunch of darts, And instead of, the way you'd simulate it is to throw a dart at the board and it hits somewhere. Oh, you're not aiming at the middle. You have to kind of throw it blindfolded or something, so that you're just kind of hitting, in random locations. And then you find out if the hit was inside the circle or not. And then you tally both the counter and the inside the circle counter if it was inside the circle. And you throw enough darts, and you can come up with an approximation of pi, using that. So it's not, you can do this entirely without any programming, but here we're going to use programming. But so this outline here is sort of just like a recipe for the process. So sometimes the question is, what process is best suited, or what process would you use for this calculation? So a lot of this kind of comes down to just using your own imagination, and really has nothing to do with programming. All right, so two of the unknowns that fall out of this are how do you simulate a hit, and how do you find out if it's in the circle or not. So here's that first. Break this guy out. Is how to simulate a hit somewhere on the dartboard. Okay, we need that point is, the hit is going to be at some location x, y, and we're going to put, in some coordinate system, and we're going to put the origin at the center of the circle. So we go back to, in fact, go back to right up here. 0, 0 is here. So we're going to pick points, x, y, all over our x, y plane here. And the value is going to range from, if this is the diameter, and that's the radius, they're going to range from -r to r in the x direction, and also -r to r in the y direction. Okay, so we're going to need, and by the way, here's two suggestions. One is, we're going to have x and y, and they're both random numbers between -r and r. And the Python documentation has a whole bunch of random functions that will return a number between two real numbers. So let's go take a look at that. Okay, so initially we want x equals some random number, and y equals some random number. If we have x and y as some random numbers, we have kind of a random hit on the board. In fact, some random number between -r. And if you need to reconvince yourself that the number needs to be between -r and r, kind of go back to this diagram here and treat the center of the circle as 0, 0. -r, r, -r, r. All right. All right, so now let's go look at the random package functions and see if there's some function that does what we need. And there's a lot of, it's the whole random package. And there's all these functions. And there's also some example code here. The one we're going to use is uniform. It takes two real numbers and returns a number in between these two. So our x, I still use common. Oh, actually, you know what? We'll actually calculate a few random numbers here. So random dot uniform -r, r. And y is going to be the same thing. And to run this code here, see, this is a case where, writing some code is probably a good idea to make sure that you know what you're talking about. If you just sort of said, use the random uniform function. You'd have to have kind of a lot of faith that this is the right answer. You know, this is going to prove to us that we have the right answer. So we're going to print using that x and y, and placeholder for y. And so now let's run this. Okay, it doesn't know about random. So in order to use random, if you guys recall, if you've used it already, you need to import random seed. You do this only once here. Do this only once at the top of your program. This initializes the random number generator, so you don't want to keep restarting. You want to follow the sequence of random numbers that it's generating. Okay, so now let's run this guy. R is not defined. Okay, so let's say our diameter is 20. But we're going to use diameter for all of our the root dimension. Okay, so R is going to be diameter divided by 2. Okay. So see, even though I'm getting errors, I mean, we're kind of making forward progress here, just like working on little things. Okay, so there's, there's a random location somewhere between, somewhere in that square. You'll find that these numbers, they're all less than 10. They're between 10 and minus 10. That's what R is. If the diameter is 20, so the width of our circle here is 20, and 0, 0 is in the middle. So the numbers all range from minus 10 to 10 for x and minus 10 to 10 for y. Okay, so let's run it again. We'll get a different number, a different point. So each time we run it, by playing around with this, you can be fairly convinced that you've got, random points that are on this board, on the square. If you see numbers that are bigger than 10 and smaller than, having absolute value greater than 10 or greater, you're in trouble. I did something incorrectly here, but okay, so now that we have this working, I'm going to comment this all out. That doesn't interfere with any code we write further down. Okay, so we've resolved this unknown. How do you simulate a hit on the dartboard? So we actually have working code for that. All right, so next thing is, how do you find out if a dart hit is inside or outside the circle? And this actually can be simplified to what we will do. How to determine if a point x, y is inside or outside the circle. We're going to assume the circle has 0, 0 at the middle. Okay, so there's two suggestions here. One is first of all, the logic is that if you get the distance from the center of the circle to the point, and maybe the suggestion is kind of written in an awkward way. Okay, so R is the radius of the circle. And if the location of a dart hit is less than R from the center of the circle, then the hit is inside the circle. And if the location of the dart hit is greater than R from the center of the circle, then the hit is outside. Okay, so a little diagram to illustrate that. Okay, so here's our dartboard again. Okay, in the center of our circle. And this little point here and this little point here are two dart hits. Now, if the distance from the center to the dart hit is less than the radius, I should have drawn a radius on here too, then the point is inside the circle. Because that using the, that should be hopefully fairly straightforward. And if the distance from the center to the hit is greater than the radius, then the point has to be outside. Okay, so we're going to use that logic here. Okay, let's see if I break this up. There's a comment here. But we're going to have x and y, and we're not going to worry about that random stuff. It's a completely separate code. This is some random number, and y equal to some random number. These guys up. It's not really modified, right? In fact, some number. We don't really know where those numbers came from. Your friend could have told you, or you could have, I don't know, rolled dice or something. But yeah, so anyhow, so you have an x and a y that represents a point, and r is also some number. Okay, so if so distance is distance from center of the circle to x, y. Okay, so we don't quite know how to calculate this right now. We will in a moment. But we can just say if a distance is less than r, and I'm going to write this in English, then x, y is inside circle. Otherwise, x, y is outside circle. So far, I mean, this is once again sort of just kind of just using your plain old logic and a little bit of math and logic. And this, raises some new unknowns, like how do you calculate the distance from the center of a circle to the point x, y. But that's pretty much the only thing that you probably don't know how to do. You know how to compare numbers, okay? So what we're going to do, actually, we're going to also make some working code here. So we're going to say, let's say x is equal to 5 initially, and say y equals 0. Okay, so you can picture that sort of like 5 out, 0. It's on the x-axis. Okay. Now let's say we're going to make r, since we've been using 20 for the diameter, we'll make r 10. So even before we've even done anything, we can see that this point xy is going to be inside the circle because the point is distance of 5 from the center of the circle, and the radius of the circle is 10. So this point xy is inside the circle. All right. The question now is, how do you calculate this distance? And distance is you can calculate through the suggestion up here. And so let's now turn that into kind of real Python. Turns out that, well, I suppose we can go, so how do you calculate the square root? Okay, so we go off to our math package documentation, a ton of math functions here. Okay, and if you eventually find, maybe search the page for square root. It turns out that math.square root is what we're looking for. We pass in a number and it returns the square root of that number. Right, so the distance is going to be math.sqrt of x squared plus y squared. We can do that inside here. Okay, and the last thing we need is if the distance is less than r, we're just going to print x, y is inside circle. And then else, print x, y is outside circle. Right? So let's run this. So math is not defined. Okay, so just like with random, we need to import the package. But there's nothing we need to initialize in the math package. So now we're going to run this. And what would you expect? Hopefully you're saying it's going to say it's inside the circle. And indeed it is. Okay, so now let's change x to say 11. This is how you go about testing your code. And that should be outside the circle. Yeah, very good. Okay, let's change y to say 9 and x to 0. So we go straight up the y-axis up to 9. That should be inside the circle. And then what about minus 9? Pull inside the circle. Okay, so and then you can, for example, you can make x and y both non-zero, which are kind of a little harder to figure out. But you could, on top of printing whether they're inside or outside, you could also print the distance. And let's make x and y both 4. Okay, so we'll see what the distance is, and then we'll see if that produced the correct result. The distance is 5.65, and that's inside the circle because it's less than 10, which is the radius of the circle. So we're pretty sure we've got our code working here, so we're just going to comment that stuff out. And notice that we didn't, kind of some important stuff here. We didn't use, any sort of random, we didn't use random to come up with these points. These are just points we're typing in because we want to test specific x and y things. We don't randomly picking test data. We want to try things and say, yeah, that's working correctly for that one. That's working correctly for that one. The other thing is this code has been largely detached from the fact we're throwing darts, whether we're calculating pi. It's like very focused. It's the important thing when you're working on an unknown is answer just the question. So we're answering just this question. Don't try to write, the whole program. Don't write, don't try to, because that's the hard way to go. Trying to write the whole thing all at once is when you start kind of spending a lot of time. You have too many moving parts. You don't know where your problems are. Here you're very focused on a particular problem. So, and once you get that problem to work, you know how to solve that problem, how to write code for that problem, and then you can move on. We'll come back to this when we're building our program. What this represents is your knowledge for how to do this. And it's an essential piece for the entire program, but and you can we've worked on this without worrying about all the other unknowns in the program or in the project. So let's finish our remaining couple of unknowns, okay? So number 4 is how you calculate alpha. And the way you calculate alpha is you go back to it's perfectly okay to go back to your spec. And I'm just going to paste that in there. You know, definitely going to comment that out because these are not variables, but we know we've got a variable for the number of hits in the circle, and we know we have a variable for total hits. So that, you know, when we come to have our meeting and you say, well, this is how I'm going to calculate alpha, that's all I need to see. I don't need to see working code. I don't need to see a complete program. I just want to see how you're going to calculate alpha. The important thing is that you read the spec, you understand, that there's a formula involved. Okay, so the last one is how to calculate pi. And likewise, you can just go to the spec and say, pi is going to be this. And that's actual code. So, but we'll still comment it out, even though we're done with the unknowns and not planning to run any code below this. Although now we're going to, okay, so now at this point is when you should write your name on the board and say, hey, I finished all my unknowns. I'd like to kind of have you review them and see if I answered the questions properly. Okay, because once I say yeah, then you can go ahead and write the complete program. In fact, we're going to do that right here. And where you start is up here where you said, here's what my program structure is going to look like. Okay. Or here's my program structure. Notice we don't have to think about this anymore. We decided this. We thought about this. We came up with an approach. It may not be the right approach. You may discover actually that you have something conceptually wrong here, but we're pretty sure it's the right one. So we're going to try it. And if things don't work out, then kind of go back to the drawing board and readdress that question. But notice how you won't have to worry about any of this other stuff, unless that has problems. But so that the nature of programming is it's kind of iterative, but more often than not you make a mistake. But once you're done with your unknowns, though, you can try to build your whole program. So here's the final complete program. We're going to initialize our variables. What are our variables? Well, they're these guys up here: the diameter, counter, the other counter. And that's really all the data. I'm going to put this down here and do a bunch of deleting. A lot of the programming you do for the final program is there's a lot of copy paste. What did I do here? Yeah. Put one of my DDD markers here. So easy to find. Okay, so the diameter, we said initially is going to be 20. So 20.0. Get rid of this stuff here. So now we actually bring our counter, turn our counter into an actual variable. Same thing with this one here. Okay, so we initialize our variables here. Okay, by the way, we're going to use R, so we're going to diameter divided by 2. Not sure if there's any other variables we'll be using, so I don't think so. Okay, so this is we're going to write a for loop. Say for, let's say we're going to throw 1,000 darts for throw in range 1,000. It's going to run this for loop 1,000 times. We're going to simulate a hit. So how do we simulate a hit? Well, here we. How do we simulate a hit? We wrote a bunch of code here. Okay. So we're going to need the random stuff. We have diameter already defined in our program, so we don't need that. Actually, I'm going to take all this stuff here. We don't need the print statement. We just need the x and the y. Paste this in here. Move some stuff around here. Import. I'm going to move to the top of our program. There. We'll go back to our for loop here, which is, okay, we don't need the diameter or radius. We need to tab these. That's a clever trick here for, if you haven't found this yet, is format. You select a bunch of lines and you indent them all at once. And we can leave these comments in for now. Okay, and then we need to increment our counter. So we generated a hit. Plus equals 1. I'm going to actually add a little white space to make it more readable. Okay. Not too much white space, but okay. And so now find out if the hit is inside the circle or not. Well, we did a bunch of work to do that. So, okay, so this is how to find out if it's inside or outside of the circle. Okay, so we need to import math. So we import math. And we have x and y already. We need the distance and then this if logic here. So we're going to copy all that. I hope you guys can follow the editing I'm doing here. So, copy. This one over here. Okay, so we're going to tab all this stuff in. You know, we don't need all of these. We'll leave all the comments. We don't want to print out the distance. I mean, if we're doing 1,000, we're going to let's see 1,000 things printed out. And here's our logic. Here's we already tested this with a bunch of cases, but we don't want to print that's inside or outside. We want to increment our counter. Okay, so in fact, here's our little comment to remind us. Okay, so there's our counter. This guy here. So it's less than that. Get rid of the print statement and replace it with an increment. And we don't really do anything if it's outside the circle. So we're just going to get rid of that code. Okay. And so now calculate pi. Well, pi is, copy that. Equal this guy. And we need alpha in order to calculate pi, so that. So a lot of this is just copying and pasting stuff you did for the unknowns. But you didn't write the whole program to do the unknown. You wrote bits and pieces just to answer specific questions. All right, and then we have just the words here, so let's use the actual variables. And I'm using the variable names that were suggested in class. They could possibly be somewhat better names, but I think they're probably pretty good. And then the last thing is we're going to print pi. What are the chances this program is going to run on the first try? Get everything above commented out. We slap together all this stuff, and copying and pasting mostly, and deleting a lot of stuff we didn't need. Okay, so let's run it. And we in fact get an answer, 3.076. Move this over here. So let's get over here. So each time we run it, we're going to get a slightly different number. All right, so we're doing 1,000. So let's see what happens now if we go to 10,000. Okay, so that's a little closer to pi. Let's run it again. It's also not too bad. Again, let's do 100,000. But simulating throwing 100,000 darts. So the more darts we throw, the more uniformly we get a distribution across the board, over the board. When we do a graphics model, we'll revisit this and we'll actually draw the hits. Okay, so that's getting 3.14, you know, pi is 3.14159. So let's do 1,000,000 hits. Okay, so 3.1416. Okay, so that's another digit each time. Each order of magnitude of throws gets us like one additional digit. It turns out it's not a particularly good way to calculate pi. You know, here we are doing a simulation that's throwing 1,000,000 darts, and we're only getting, you know, 3 or 4 valid places or digits. But it's you know, certainly if you're desperate to calculate pi to some degree of accuracy, there's one way to do it. This program gets a little slow after a while. Not after a while. The more zeros you add here, the slower it gets. I don't know if you notice that 1,000,000 took quite a while to calculate. I'm not going to go into this, but it turns out probably a lot of the times is chewed up by this square root thing. And there's a trick we can play to eliminate using square root with a little additional math logic. We're not going to do that, but make it substantially faster by getting rid of the square root. All right. So to kind of summarize, this was not, you know, an exercise in giving you the recipe for doing this particular program. Although you know, this is a program, you know, this is a project you'll have to do. Do it exactly the way you see it here, the way you watched me do it. One unknown at a time, specifically answering the question. You know, each one of these really, in a way, kind of is independent of the fact we're trying to calculate pi. You know, probably the only thing where, you know, pi is even mentioned is in this very last unknown, you know, how to calculate pi. All the other things are just largely kind of tallying number of simulations, the results of the simulations, structure your program, some of the geometric stuff, you know, how to come up with the random point, and then how to, and this is the geometric part here that I'm trying to figure out, you know, if it's inside or outside the circle. So the main message I want to leave you with after doing all this is this is how you should do all your projects, every single one of your projects. I'm not sure how clear I can make that. None of your projects should be just sit down with an empty file and start typing code. With every single one of your projects, the first thing you should do is paste in your list of unknowns, format them nicely, and then start working from the first one to the last one. When you get to the last one, request a meeting. I'll briefly look at what you did. I'll say, yeah, I think you're ready to write the final program. Don't try to write the final program, you know, until I've had a chance to see what you did for the unknowns, because the test for whether you did the unknowns properly is is if you can more or less just copy and paste stuff and build this program. The way I did, I didn't have to do. I did almost no thinking. I just gonna like, okay, so, here, where do we put the variables we're initializing? Where do we put, the code to come up with the hit, the random numbers, the random locations. How do we, how do we figure out if it's inside the circle? That I wasn't thinking about how to do it. I was just, kind of putting code where it belonged. We thought through the code before that. So, all right. So, okay. So that's one of the projects. I'm gonna do another project to kind of repeat the process here. Somewhat shorter project. The one about calculating a payment. So, okay, so I have an empty file. No, I don't. Okay, so there's our empty file, and we're going to go to our spec here. Okay, so for this project, we're going to write a program, two programs actually, one that computes a monthly payment, another program that figures out the interest rate to get you down to a particular payment amount. The stuff I do in the video will be only for the first program. Here's the formula for calculating a monthly payment. Okay, so we'll be able to kind of pick off what data is involved here. And here's our unknowns. So the very first thing you should do is copy and paste into an empty file. Add the comment markers. All right. In addition to the unknowns, I'm not sure maybe necessarily they're in the correct place here. I'll talk about this in a second after I'm done formatting. All right. This is the test data you should try. Like, so that if you use $1,000 at 5% for 12 months, your program should calculate $112.83 to verify that in fact did your coding correctly. It's possible to mess it up with a missing set of parentheses or something. You're not going to get that amount. If you don't, then there probably is something you need to do to your code. But before we write the whole program, we're going to work through the unknowns, just like we did for the Dartboard program. This second program is going to try to figure out an interest rate that gets your payment down from 112 down to 100. All right, so we're going to only address the first three unknowns. The other three unknowns apply to the second program. All right, so what variables do you need, or what data is involved? Okay, probably be that. So we break out that first unknown of this fashion. Then we go to our write-up, and if you kind of look through this, there's the monthly payment is a fraction. It's the numerator over denominator, where the numerator involves the interest rate and the amount borrowed. So those are two things we're going to need: interest rate and amount borrowed. Because interest rate, amount borrowed, and anything else. Okay, the denominator has interest rate and the number of months. So right. So it doesn't look like there's really anything else left for me. Remember to reduce our interest rate to decimal form by dividing by 100. All right. So that is all you need to do for this first unknown. And we can do something like write a little bit of commented out code to make life a little easier when we're building our final program. Let's say equals some number borrowed some number. Don't worry about the actual number right now. Some number. Oops. And we're just going to comment these guys out. Now, so we don't have to worry about the formula. We don't have to worry about anything else. We just sort of identify what data is involved. What variables do you need. Okay, so now we're going to talk about program structure. That's all our data questions. Okay, so is this going to loop? Or is it just going to like initialize some variables, do some calculation, and you're done? It's the latter one. It's going to be the linear. So the linear looks something like this. It's like initialize some variables, uninitialized variables. Do calculation. Right? There's a program structure. That's all you need to do for 2. So you should not be, trying to write the whole program here. Just kind of using your logic, sort of your basic intuition, for what you think the program is going to look like. You should be able to do this in a minute or 2. And overall, you should be able to write this program probably in 15 minutes using this technique. Okay, so now we get to probably the hardest part of this is, but not too hard, I don't think. How is the monthly payment computed? Well, go back to our write-up. Monthly payment is this, the numerator and denominator of that. So, the where, the and. Yeah, comment these guys out also. Actually, even the and the where. Right? So the project spec has written this, provided the formulas in Python format, so you don't have to worry about coding this. I guess I should have written this in just plain old kind of math format to have you convert it to Python to have some practice. I would actually probably recommend that you type in these formulas just so that you can practice with, put the divide and the parentheses around this and the star star. Because part of the reason for doing this project is to practice your writing Python. You're not always going to get like somebody handing you the code. By the way, I know this is sort of in a weird order, but I'm going to leave it at such, and we'll reorder them when we're doing the final program. Okay, so these 4, 5, and 6 pertain to the second program. So without much effort, we have answered resolved all the unknowns for the first program. So final, complete, program 1. Okay, so where do we go? We go to our structure here. Copy and paste it. Okay, so here's our variables. We're going to initialize our variables. Okay, so we got uncomment these guys. And the interest rate is going to be basically our test data divided by 100 over here, 100. And then the amount borrowed is going to be 1,000. And the number of months is going to be 12. Making all these real numbers. Okay, so that's all we need to do here. And that's how we know to really think about anything. Use copy and paste. Okay, so now we're going to do the calculation. And the calculation involves these couple of formulas. Okay, so paste them in here. And now we're going to get rid of the where and the and of course we need to calculate our numerator and denominator before we calculate the monthly payment. And we need to uncomment these guys. Now we probably want to know what our monthly payment is, so we're going to print monthly payment. Okay, so what are the chances this is going to run? Pretty good. And there we are. So it's 112.82, and let's see, it said, oh, let's see here. Or 0.83, so we coded our formula properly. I'm going to jazz up the format of the number format. You don't need to know this, but there are there's a lot of web pages, in particular the Stack Overflow thing, that will talk about things like how can you know, this person is asking, you know, I want to print things out, you know, here, display a float with 2 decimal places. So like if you're showing money, you want to show 2 decimal places. You use this funny, we're going to use this one here. There's a lot of different options. Where is it? We're going to use something that looks like, I had one here that was, I got one from here, got one here somewhere. I got one from here. Oh, something that looks kind of like that. But let's go back to our code here. We're going to put in our placeholder, and then you do :0. You know, the other one said A something or whatever. 2 decimal places float, and let's in fact put a $sign in front of here, and maybe even say monthly payment is, right? So let's run that. Now we formatted this nicely. And that's it. So that's, it only took, I'm not sure on the keeping time, but you know, probably less than 15 minutes. I would expect that you can also do this quite quickly, especially if you watch the video. Once you get this program to run, then your next 3 unknowns to resolve will be for the second 4, 5, and 6. Notice that there are similar questions. Okay. So, all right, so to kind of wrap up here, by the way, there's 4 projects. Everybody should start with the loan payment calculator and work on 1, 2, and 3, and then contact me for, you know, basically in class, or you know, if you're doing this before the next class, email me for the 5-minute meeting so we can look at this, you know, and look at your unknown resolution, and see if you're ready to write the final program. All right, and then after that we can set some more goals. So kind of wrap up. The purpose of this wasn't to give you the recipes for loan payment and computing pi, although sort of, you know, basically it's a consequence of doing the demos. Okay, but the purpose was to show you how to use a list of unknowns. Okay? Because as you work through unknowns, you're kind of thinking about sort of focused parts of the problem. And I'm interested in seeing what your thinking is. I'm not interested so much in your code. Sometimes you'll have to write code to show, I won't believe that you know what you're doing until you show me working code, like, the business with a point inside and outside the circle. I want to see I want to try your code and see that, that it's actually reporting correctly whether a point is inside or outside the circle. But, for some of the stuff, I'm just interested in your thinking, like the program structure, just, which one did you pick and what additional little comments did you add there, to provide details of what your program is going to be doing. Focus on only one question at a time. Focus only on the question. Don't worry about anything outside of that question. Like, for example, when we were doing is the dart hit inside or outside the circle. Don't worry where the point comes from. Don't worry about random. Don't put random if you're writing code for this. Don't generate those points randomly. Just pretend nothing outside of this question exists while you're working on it. And go through the unknowns one at a time, modeling your work kind of on what you've seen here, because I'm not going to do this for this points along curve or Fibonacci or for a lot of the other projects. You'll get a list of unknowns, but you're not going to have a video that shows you like how to do it. So what you bring to the meeting will be what you come up with yourself. But model what you come up with using sort of the same approach that I've demonstrated here. All right, so everyone's first assignment, since we haven't had, well, basically, have to pretend we had a meeting where you were assigned some unknowns to work on. Assume we had this meeting, and the first 3 unknowns in the loan payment project are the ones you're supposed to work on. So when you feel you have the satisfactory answers to those unknowns, and I don't expect that to take you more than 5 or 10 minutes, especially if you watch this video carefully. Then let's have a meeting. I want to look at what you wrote up for resolving your unknowns, and then we can have our meeting. And then in class, when you reach the end of your list of unknowns you're supposed to be working on, put your name on the blackboard. And if you want to, if it turns out that you're doing something between classes, during the week, we can have a Zoom meeting. Once again, a brief 5-minute thing, specifically for the purpose of looking at the work you did for the unknowns. The projects will get progressively harder, and the list of unknowns will get longer. So the loan payment project in particular is kind of reasonably easy, so you kind of get some practice with this unknown process. And kind of likewise the pi thing. And then the other projects are, no video to watch, and but hopefully you'll be pretty good at doing that by the time you get to the points and the Fibonacci projects. Alrighty, okay, so quiz is at next class, and hope this was worthwhile watching, and let me know if you have any questions.